point is we've been talking about arcs and angles, correct? Okay? We've been talking about arcs and angles. Last Thursday we talked about some tangent stuff, didn't we? But we were talking about the lengths of the segments. Remember we were doing Pythagorean theorem because we were finding those lengths of the sides. Everybody good with that? Now we're going to talk about these chords, and we're talking about the lengths of those segments. So if I showed you the picture up here on the right, what's one of the first shapes you should think about, or something that we've been talking about? What does it look like? Bow tie. Very good. So this first one right here is an example similar to what we did with bow tie. The only difference is now I'm not talking about arcs and angles, I'm talking about the lengths of the segments. Okay? I want you to copy down right here the rule. It's not going to really make sense until just a minute. Okay? You multiply one chord, and it's going to be equal to, when you multiply, the other chord. Okay, I know that doesn't make sense. I'm going to explain it here in just a second. Okay, so copy that down into that rule section there. All right. So what does that mean? Okay, what it means right here is this is a chord, correct? I need to multiply the letters on that chord. What are the letters on that chord? A and, good. So I would multiply A times B. And that would be equal to the other chord multiplied. What are the letters on the other chord?
C and D.
C and D. So I would multiply C and D. A and B, or A times B, has the equal C times D. Whatever it is. Okay, so I want you to look at number one, and you're just trying right now, right? You could be right or wrong. I just want you to try to set up number one. How you did. So would you all agree that this is a chord right here?
Yep.
What are the numbers on that chord?
3 and 6.
Good. So what is 3 times 6? 18. And we just said a minute ago that that has to be equal to when I multiply the other chord.
2 times X.
Well, 2 times x, right? Which is 2x. Everybody good?
Yep.
Now what do I do?
Divide by 2.
Good. So we're going to get x by itself, so now we're going to divide by 2. So x is equal to 9. That's it. How many of you have that on your paper? Good. Okay, how many of you are like, oh, that's easy? Okay, there's going to be some things that aren't easy, but that's the basics. So now I want you to try number 2 and number 3. Number 2. Would you agree this is a chord right here?
Yeah.
What would I do?
Multiply.
Multiply what?
8 by 8.
Good. What's 8 times 8? 64. Very good. And that's going to be equal to the other chord. Isn't this the other chord? Which would mean 6 times x, which is 6x. And then what do I do?
Divide by 6.
Good. Divide by 6. So x is how big?
10.6.
10.7. Great job. Now on betting number 3, you struggled a little bit, right? And you had an internal fight in your head as to what to put. And it's either this or it's this, correct? So we have a chord right here. So that's 6 times 5, which is 30. That's going to be equal to the other chord, which is 2x times 3x. What's 2 times 3?
6.
Good. What's x times x? X squared. Remember, x times x, the exponent is a 1. I'm multiplying, so I really need to add my exponents. That's how I get x2. X squared, sorry. Now what do I do here? How? Divide by 6. So x squared is equal to what? 5. Now what? Take the square root of it, right? So x equals the square root of 5. Mr. Ramsey, I don't even know how that even fits into this problem. Right? X is the square root of 5. So right here, I have 2x, that's 2 square roots of 5. Would you agree? And then 3x would be 3 square roots of 5. So what is 2 square roots of 5 times 3 square roots of 5? Well, what's 2 times 3? 6. Isn't this a pair? What happens when you get a pair?
It goes outside.
You get to come out of the house. What's 6 times 5?
30.
Oh, isn't that what 6 times 5 is? Are you with me? Okay. So, is that one a little more difficult? Sure. And it's okay. Okay? Alright, look at those pictures in the next couple of boxes. I want you to compare and contrast them in your brain there. Okay? Look at those two pictures and tell me, how are they the same? How are they different? Kind of. Remember, have to like tangent stuff. So what is the same between those two pictures? They're circles. What else? They're secants. What's a secant? One that goes through a circle, correct? This is a secant here as well, right? And this is a secant right here. Is that one a secant?
No.
What is it?
Tangent.
Tangent. You have to watch out for those tangents. They're trouble. Trouble tangents, right? Okay. So what we're going to do first is I'm going to give you just the formula of how to work these problems. And we're going to do it with something called parts and wholes. A part is on the outside only. So right here, this is a part. This is a part. This is a part. This is a part. Everybody got the parts down? Okay. And then this right here is a what? A hole. Okay, what would this be right here? Hole. Then right here I have a what? Hole. Oh, but wait a minute, what about this other one? There is not a hole, is there? There's just a part. There's only a piece that's outside of the circle. Okay? Now, here's the most important part. If I told you that this piece right here was 8 and this piece was 6, what would you do to get to the hole? If I told you this piece was 8 and this piece was 6, what did I do to get to the hole? Times? Add. You add two pieces to get a hole. Write that really big on your paper. You add 2 pieces to get a hole. And here's going to be your rules. Part times hole equals part with equal sign times hole. But over here, I have one that doesn't have a hole, correct? So I can't do part times hole on this because I don't have a hole. So when you don't have a hole, in other words, when one of these lines are a tangent, you're just going to do part squared. And that's going to be equal to part times hole. What do you do to get the hole? Add. Okay? Does it go this far?
Yep.
Okay, so let's look at number 4. Somebody tell me what's this called right here? Part. What's this called right here? Part. What's this piece right here called?
Hole.
Hole. What do I have to do to get the hole? Add what?
6 to 18.
16 and what's 16 plus 26? Okay? And then what do I do to get this hole? Add what? The part, which is 18, plus this piece, which is, and we're adding them, right? So this is 18 plus x. Everybody okay there? Okay, and my formula is what? Part times whole equals part times whole. So what's my part again on the top?
16.
What's my whole? 42. How did we get 42 again? We added 16 and 26. Okay, what's the part on the bottom?
18.
18. What's the whole on the bottom? 18 plus x. Okay, so we multiply the part times the whole. Oh, wait a minute. If I'm looking at this equation, what am I going to have to do? It's what? So what about the parentheses?
Multiply.
What's that called? Distributing, very good. So right here, we're gonna have to distribute out. So somebody tell me what 16 times 42? I'm sorry? 16 times 42.
672.
672. What's 18 times 18? 324. And then 18 times x is 18x. Now somebody tell me what would I do?
Solve for x.
Solve for x how?
We can subtract the 234.
Subtract 324?
Both sides.
That's okay. What's 672 minus 324?
348.
348. Now what?
Divided by 18.
Divided by 18. So x equals what?
19.3 repeated.
19.3 repeating. That means that right here, this is 19.3. Okay, I want you to try number 6. Okay, so somebody tell me what's this called right here?
Part.
Part. What's this called right here?
Part.
Part. Okay, what's this right here called?
Whole.
Oh, I have to add those two together. Well, how big is this one?
Don't know.
It has those lines.
Oh, it has these lines. What do these lines mean?
That they're like equal.
They're equal, they're the same. That means this one's 8. So what's 8 plus 8?
16.
16. So that means that my whole is 16. Everybody agree? Okay, this is my whole right here, correct?
Yep.
What do I have to do to get my whole?
Both sides.
We need to add both pieces, right? So 2x plus 6. Can I put those together? No, because one has an x and the other one doesn't. So now let's set it up to solve it. Remember, it's part times whole. What's the part on the top? 8. What's the whole on the top? 16. What's the part on the bottom?
6.
6. Very good. What's the whole on the bottom?
2x plus 6.
Good. 2x plus 6. Right? What do I need to do now? Distribute out. What's 6 times 2x? 12x. What's 6 times 6? What's 8 times 16? 128. Now what? Good. Subtract 36 from both sides. And that gives me what? 92. Now what? Good. Divide by 12. So now I know that x is equal to what? 7.6 or 7.7? Good. How many of you had that? A couple of you? Good. Okay? All right, so let's go back up to number 5. What's different about number 5 than the ones that we've been doing? Good, it has that tangent, right? So what do we call this right here?
Part.
A part. What do we call this piece right here?
Part.
A part. And what do we call this piece right here?
Whole.
The whole. How big is the whole? What do we have to do to get the whole?
15 plus x.
We have to add, right? The part and this little piece right here, so it would be x. Now, because right here did not have a whole, then it's part what?
Squared.
Part squared, right here, part squared. So this would be 18 squared. What's my part on the bottom?
15.
15. And I'm going to multiply that by the whole thing, which is 15 plus x. Now what do I have to do? Very good. We need to go out and distribute. 15 times 15 is 225. And then 15 times x is
15x.
15x. What's 18 squared?
24.
324. Now what do I need to do?
Subtract 2.
Good. Subtract the 225 from both sides. Then you get what? 99. Now what? Good. Divide by 15. So x equals what?
66.
6.6 or 6.7?
6.6.
6.6. Okay, I want you to try number 7. All right, so let's try. Okay, so right here, what do we call this? Part. What do we call this? Part. And what do we call this right here?
Oh.
The hole. What do we have to do to get the hole? What do we have to do to get the hole? Add. Add. What do I add? Good. X plus 21, correct? Okay, so here, do I have a hole? So what do I put? Good. 35 squared. What's my part on the bottom half? Good. And what's my hole? 21 plus x, or x plus 21. Now what? Distribute. 21 times 21 is 441. 21 times x is 21x. What's 35 squared? Okay? Great. What do I do next? Good. Subtract 441. And you get what? 789, is that right? 784. Now what? Divide by 21. So x equals what? 37.3 repeating. That's a 7. Sorry.
Excuse me, someone's gonna be technically
Have a good day.
One, star down for 2, and then star one, final one, 115.
That's just all it's off.